Scientific notation, section 1.2. Some of you will probably have to watch this whole video in like its entirety, really focus and learn how to do this. Some of you might just have to kind of review over it because you've learned how to do this in your math classes. Those of you that already know how to do scientific notation, make sure you go ahead and watch some of this, look at it real, look at the notes for a second, because there are some things in science class that I'm very picky about versus your typical math class. So that's just something that you might want to look at. So here we go. Scientific notation we use a lot in science class because we're talking about things like atoms and molecules, which are very small, and so we have a large number of those things, and so we use scientific notation to express that. So we're not talking about lots of zeros. Scientists don't like zeros, and so we use that to express it's an easier way to do it. So we call it scientific notation. It's based on powers of 10. It's just an easier way of doing it. Just some helpful tips. You move the decimal to where there is one digit in front of the decimal spot. So that's kind of the key, and that's what I was talking about for some of you that already know how to do scientific notation. You want to make sure that there's only one place in front of the decimal. Okay, that's the key there. So you want a number and then the decimal. So, and I'll point that out when we do an example here in a minute. That's kind of the big key point. And then you have all the other numbers after the decimal spot. And then if you move the decimal to the right, it's negative. Okay. If you move it to the left, it's positive. If you didn't move the decimal at all, then it's going to be 0. Okay, so those are all the things that we need to talk about with scientific notation. And we'll do some examples here in a minute. Alright, so here's a couple examples, and I might even add a third one. So the first one, we have this huge number, and they want us to put it in scientific notation. Alright, so first of all, we want to put the decimal right here. So, and it's not present, but it would be right here. So we want to move it all the way to where that arrow is. So your number in scientific notation is going to look like this. Times 10, we have some number right here, times 10 to some power right here, meaning you're going to have an exponent. So I want it to look like 2.5 times 10, and the power is going to be how many I'm going to move it. Well, I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9. It took me 9 moves to get it there. So it's going to be 9. Now, on the previous slide, I said that if I moved it to the left, that it's going to be positive. If I move it to the right, it's going to be negative. The other thing I think of is in terms of money. Sometimes that helps me. Like I think, oh my gosh, if I had this in terms of money, that would be lots of money. That would be a positive thing. So this is going to be a positive exponent. So that helps me remember that this is positive. I don't know. That's something to help keep things straight, because I don't know. This whole left is positive, right is negative thing gets me confused. I try to keep things simple. Okay, so this would be your answer, 2.5 times 10 to the ninth. And of course, if you had other numbers after the 5, you would write all those. And we're going to get into something called sig figs here in a minute to tell you if there were other numbers, how many of those numbers you would write. But that would be the answer so far. Look at this one down here. Again, point, and you have all these zeros, 5, 6. I want that decimal to be right here. I want to move it in between the 5 and the 6. So you know you're going to have 5.6, and then we have times 10, and I need to move this decimal. I need to move it 1, 2, 3, 4, 5, 6. So I'm going to move it 6 places. Now you can think, well, I just moved it to the right, so that's negative. Or think about it again in terms of money. This is like less than pennies. So that's, if I had that in my bank account, that would be a sad thing. That would be in the negatives. I mean, I'm almost less than dollars, so that would be a sad thing. That would make me really sad, so that's a negative thing. So that would be a negative number. So that would be the answer for that. The other thing is, you could think about it this way, like up here on the first example, look at how many zeros you had. I had 1, 2, 3, 4, 5, 6, 7, 8. And then I moved it over one number, 9. Look, that's how many places I had. So if you're not real good at this whole, like, you know, I a lot of times just count how many places I had. That's the other thing I do here too, is I just count the number of places. 1, 2, 3, 4, 5, 6. You can do that as well. Just some little tricks. Kind of a third example too. Let's say if I have the number, I don't know, let's say the number 7. And they ask for you to write that in scientific notation. Don't just think you can leave that as an answer. You would actually need to write that as 7 times 10 to the 0. Anything to the 0 power is just a number. So if they were to take the number 7 and you just want to write that in scientific notation, that would be your answer. So make sure that you're aware of that a number by itself can still be written in scientific notation. So you might want to add that to your notes. So there's just some examples of how to write some numbers in scientific notation. The other thing you need to be able to do is to go the opposite way and then write something called, write it in what's called standard form, and that's going opposite. So taking numbers and writing them without exponents. Just some helpful hints. It's to do the opposite, and that's why I get confused a lot of times personally with the whole like right is positive, left is negative, is because here now you got the rules just going opposite. So right, you go right for a positive exponent and left is a negative exponent. So you just move basically the decimal that number of times. So I'll show you some examples here. So again, if you could kind of think in terms of money and think about like, okay, positive and negative, like that's good, that's bad. So here's what you do. So they say write 2.25 times 10 to the negative 6 in standard form. What I do is I start out with the number. I say, okay, 2.25, oops, let's see. I don't really have an eraser on here, sorry. 2.25, I wanted to write lots of 5s today. So what I would do is, I take this decimal, and I think, okay, negative, that means that I'm going into my negative bank account, meaning that instead of this being a big number, this is going to be a small number, so that means that it has to go this way, because I'm getting more negatives. So I'm going to move this 6 times, oops, this way. So 1, 2, 3, 4, 5, 6. And now everywhere that there is a hole, I have to put a 0. So now I have 1, 2, 3, 4, 5 zeros. Or for some of you that are picking up the tricks, I had to move it around the 2 and I have to have 5 zeros. So 1, 2, 3, 4, 5 zeros, 2, 2, 5. There's my answer. Okay. Now, if it's positive, that means it's a good thing, right? Meaning that I start out with 3.36, and it's a good thing. Positive is good, meaning that I'm going to be raking in the dough. So that means I'm going to be moving it to the right. So that means I'm going to come around this 3, come around this 6, I'm going to come around 5 times. I've already come 2. So there's 3, there's 4, there's 5. So 1, 2, 3. So there we go. So basically what I did was I moved 2 and then I added 3 more zeros. So 3, 3, 6, and then 0, 0, 0 is my final number. And you guys need to do this when you write them in standard form. Please don't leave me with these whole, like, I don't want to see 2 decimals in your answer. I want to see a final answer, preferably with it rewritten with a nice comma. You know, if it's a big number, you know, rewritten with a nice decimal, one answer. I mean, I don't want to see your think areas. I want to see a nice final answer. Okay? So, but that's how you do standard form. And again, you know, you each will come up with your own ways of figuring out how to think about this. Sorry about the dogs in the background. So if you have questions, big thing is just practicing this. And we'll do some more practice on our own.